Well, here we have K7500 number 2 on the bench here, and let's give this one a look over and see what we have going on. Now, I'm not going to go through and do all of the testing that I do on this on all of these videos because it's redundant. There's otherwise they'd all be an hour long, like part 1. So if you're finding this video without seeing part 1, or if you're going to end up seeing number 3 or 4 before you watch part 1, watch part 1, and that'll show you what to test and how to test everything to make sure it should power on. Or if you're having issues with your 7500 where it's ticking or dead, refer to part 1 and you'll see what to test and how to test it in order to see if there's or what the problem is in your power circuit. So I'm not going to go through and do all the testing on all of this stuff, otherwise each one of these videos will be an hour long. So what I'm going to do is we'll just do some quick inspection to make sure nothing's missing and nothing is burned or nothing is out of whack. And then when I cut away, and we'll get it, assuming I find nothing wrong that would indicate a power issue, we'll go ahead and get it on the tube and fire it up and test it and see what we have going on. And in an effort to make these not as long as part 1. So it appears to be complete. We've got our remote board. None of the pots are broken. They're all in good shape. So I'm going to disconnect it and put it aside. And then our neck board is also complete, but it's got some pretty bad connections here for the transistors like the other one. It's not as bad, but you can see someone's added a huge solder bridge here and a huge solder bridge there instead of just using component legs. So I have a suspicion we'll have more color issues, but we'll see. And they've also changed out this resistor here, so I'm wondering what's going on here with this because this is different and this is different. So I'm betting we'll have some type of color issue. I think it's RGB if I'm not mistaken. But we'll find out. So anyway, yeah, and I made a mistake on the last video, and the Arcade Buffet was kind enough to point out that on these revisions of neck boards for the 7500, each neck board is different. There's a different neck board. Well, they're all the same neck board, but they have slight differences between the U2000, U5000, K7400, K7500. It turns out that these mods that were done on the previous video, part 1, were actually done on purpose. So it didn't. Those components that I replaced didn't need to be replaced, but they're not going to hurt anything by staying in. But they didn't need to be. These mods, can affect color, brightness, things like that. But putting them back in on that neck board and testing it, I had full bright colors, so I'm not really too worried about it. I can leave them in there; it'll be okay. But yeah, these were supposed to be removed. So, and he's also right. If you look here, the center post has no solder on it. And this is obviously factory stuff since the other one was like that too. Anyway, so let's disconnect our neck board just to get it out of the way. Again, sorry, we'll zoom out. Disconnect your connector off the main chassis. We got our G2, and we'll fold open our focus and take that out. And we'll set aside our neck board. And we'll take a closer look at it here in a minute. But okay, all the caps are original. Well, yeah, it does look that way. Some of them have been replaced. This one's been replaced because the glue is not on it. This one's been replaced, but for instance, like this one has not. So some of these have been replaced, some of them have not. But I talked with the owner of these chassis, and he said don't worry about replacing anything because when it comes to flybacks and reflows and cap kits and stuff, he can do all that. He just wants them all fixed and tested and working, and then he can do the other stuff later. So I'm not going to end up having to do any of that, assuming that the caps aren't causing a problem. There's a leaf down in here. There's a leaf. Alright, so everything looks complete. The linearity coil is not broken, but it's off of the ferrous graphite thing there, so You'll notice if you actually have this running and you go like this and just move this around, you'll have linearity issues start happening because it needs that magnet in there intact. So I'll have to hot glue that in place or epoxy it later, but that's something to be mindful of as well. I don't see any missing components. It all looks okay. Just at first glance anyway. We'll find out when we try and power it up. The back side, let's get rid of this thing. Push down and lift up and then slide off one side. Okay. Well, nothing too bad. You can see someone's done some repair to it previously. There's some questionable. It's going to be hard for you to really see, sorry. There's some questionable stuff going on here. It looks kind of dirty. But otherwise not too bad. No scorch marks or burns or anything obvious. That's what I'm looking for. It needs reflowed, the power connector and header pins for your neck board, header pins for the remote board. Those are standard for what I always do. And some various strategic stuff. The transformer solder pads look pretty good. These have a tendency to have cracked solder joints on the on this transformer here, right here, yeah. These right here. So give it a good look over when you have this. Header pins for your degauss and your horizontal and your vertical for your yoke. But this seems to be okay. So I'm going to do all of the power testing or testing of components, HOT, SMPS chip, power supply section, Q703, the whole 9 yards, and assuming all that's good. Again, go back to part 1 if you want to learn how to do all that and test all of that. And then assuming that's all good, I'll cut back here and we'll get it hooked up to a tube and we'll see what's happening with it. If I have any problems taking my readings, I'll go ahead and talk about that. Well, you know what? I think on second hand, I'm going to go ahead and just test it on camera. There's no reason not to. It won't take maybe about a couple of minutes. The reason it took so long before is because I was narrating and talking about everything. So this time, I'll just go through and test without actually talking about it. So that's probably a better idea. That way, so if you're watching and you're new, you don't have to actually go back and watch a whole other video. So yeah, I changed my mind here on the fly. So let's check this out. Okay. Let's just go to HOT. That's good. And that's good. Okay, HOT appears to be good. Let's do Q703. It should be, I think that's closer, it should be like 1.0, but that's close enough. Other side. Oh, okay. Oh, dang it. Alright, that's good. Switch mode power supply. Is that the right? Nope, that's the wrong ones. There we go. So that's correct. That's correct. 1.7, 1.9, close enough, and 1.0, 1.1, close enough. So switch mode power supply chip is good. Let's do our voltage regulator. 1.0 and 0.5. Yep. Voltage regulator is good. Let's test our resistor R104 to make sure all this side's good. 10K ohm, that's good. Alright, well, again, if you got a bad power chip, something in here is probably bad. So since this tested good, I don't worry about anything in here. And since this tested good, I don't worry about anything over here. So most likely our power supply section is good based off those readings. Q703 is good, our HOT is good. Let's do our, and let's leave it on ohms. Let's go to our polycaps. That's not shorted. That's not shorted, and that's not shorted. So that's going to be about it. We can test our other diode in here. What was this? D707. This chip here. This leg is negative. This leg is positive. That's good. We've got our width transistor installed. Someone put attach me on here. Well, I was hoping to find at least one of these with a bad power supply section or something going on where it won't power up, so for, you know, educational purposes. But so far, I've got three, the 7400 and these two 5000s. I'm sorry, the 7400 and these two 7500s. Sorry. So far, they seem to be working fine. So let's get our neck board checked out here. Other than the mod up here, it looks like everything is here. And yeah, there's another mod here. I noticed that this resistor, what is this, R500? Normally there's a resistor that goes from this point here. Let's just zoom in under the light. Sorry, I keep forgetting. Okay, there's a resistor that normally goes here over to here. From this point to this point, it's R500. And some of these have them, some of them don't. So I know that there's, I mean, I knew that there were different revisions of the board because they actually have the revision on the label here. Someone's peeled that one off, like HIJ, things like that. But, and they'll all work. You can grab any of the three different boards or whatever, how many there are, and put them on any of the different chassis, and they'll work. But yeah, like Arcade Buffet was saying on the, he made a comment on part one about this, that you might have some that'll cause it to be, the image to be darker than the other ones or things like that based off of your mods, but they'll all work. So if you need a neck board, you can use any of the revisions, but you'll have to probably change other settings to make it brighter or darker or better, sharper, whatever have you. So, and the back side here, let's zoom in. And yeah, all of these, most of these are always a shit show because of this heats up so much, and the pads are so crappy that they just lift right off the board. You can see that this is, all these are lifted right off the board. So it's pretty dire, but let's do our continuity and do some testing. I'm suspicious because this has been replaced and so is this. But let's get our meter again here and back out slightly. Okay, let's test our main chips, or our main transistors here. The way these work is you should have one leg should be 0.5 something like a normal transistor or diode, and the other side should be open. So the way these works is if you've got continuity to your diode or to your transistor, like for instance like this. There we go, 0.6. This other leg should be open. Yeah. 0.6, open. Now we'll go to the next one here. 0.6, open. This one, 0.5, it's a bit low. And, oh, look at that. So if we go to these two legs and touch them, it's 0.63, and that's shorted. 0.63, 0.63, shorted. Well, that would correspond to my suspicion because you can see how different this is. I don't know if maybe they changed these two out. I don't know, but this one, yeah, that's shorted. Not surprised based off the way it looks and the fact that this is highly suspicious with the two different components there. But we can test our resistors. They should be 2.7K, if I'm not mistaken. Yeah, 2.6. 2.6. And is this one any good? It is good. Okay. Well, We found that without even turning it on first, so I'm skeptical of whether or not replacing this will make the color come back. Like I say, I think it's red, green, blue, because this is red, green, blue. The pots are red, green, blue, so I think this is red, green, blue. So if I was a betting man, I'd say we don't have blue, but let's go ahead and replace that. I still have my tub here. I got a vertical IC extra. I got another transistor. It looks like that may be, I've got a bunch of stuff in here, extra heat sink. I got an extra chip here that is U500 actually. I kept calling it 501 in the other video. It's actually U500. I've got, oh, I have a whole nother. I got 2 vertical ICs. Well, that works out. What else? I got plenty of the resistors. And I got a voltage regulator. That's the Q701. Was it 701? 101, Q101. I've got a busted audio amp from an MK2 soundboard. And then I think this is an extra one of these, if I ever need it. And yeah, here's another. No, that's the, where is it at here? Here it is. So I actually have 2 extra transistors here and a bunch of other extra parts for these types of chassis. So let's just, let's make sure that this one is good. Well, I can't say before testing, but we'll do some comparative readings here on these two and make sure that they read what they're supposed to. Where'd my, here it is. Okay, so we'll go to the base. We'll test one leg. Oh, herpaderp, alright. Alright, that's good, and open. Alright. Go to this leg. That's good, and bend these up a bit. There we go. Center leg, good, and other leg. Oh, interesting. This one is no good either. Nope, that should not be. Well, looks like this is not any good. In my spare parts, and wasn't any good. And it is definitely C3782, which is what these are, 3782. And base 0.6, and that's not good. So, trash. Again, you can test this one. You should have a connection on one side, the other leg should be open, like that. So, interesting. I had a bad one in my extra stock. I'm glad I found it. Okay, so I'm going to leave that out because I'll be putting this shield in there. Slide off of there, damn it. There we go. So I'm going to save this heatsink and put this away. And now we will extract this, and then we'll test it out of circuit to make sure that's the actual issue and not something else that's causing it to read that way. Because again, this could be bad, which we'll test just in a second, but this could be bad, this could be open, this could be open, over here could be, one of these could be bad, which I guess would be this one on the end. Any of them. I've seen these go bad that cause this to read shorted. This could be bad. Any number of things could be wrong, not just this. So if you have color issues, it's always not just this. These could be open. Like I said before in part 1, there's all kinds of problems on these that could cause color, whether you have all of one color or you're missing a color. It could be not necessarily always just go to this. It could be any of these or these transistors here, or these transistors, or these resistors, or these resistors, or the main U500. It could be any number of things. It could be an open bias pot, so you need to inspect very thoroughly. So while the desoldering gun is firing up, let's test these two resistors here, this one and this one, and then we'll test this transistor there. So I believe these are the opposite. These are center. The base is the positive lead on these ones here. So if we do, oh, that's good, and that's good. Yeah, so this transistor appears to be good. Let's test our resistors here. 0.7. So that one's good. And that's good. 150 is about right. Yeah. So we know that this resistor is good too. So I bet you we just have a bad transistor. So we'll spread those out like they're supposed to be, and we'll change this out, and then we'll test it. And if assuming the testing is good, I'll come back and redo all of this. There's another piece of a leaf. Well, we'll test it, and assuming that's good and everything is working, like I say, I didn't find anything wrong with this one on power, so it should power up at least. And then, I mean, it could be in vertical collapse, I don't know. So let's at least just get this going and hooked up and tested and see where we're at. And then I'll come back and kind of clean this up a bit, make it a bit better afterward, like I did on part one. So, okay, we are ready here. Okay. Should come right out. There you go. So test it out of circuit. What can I set this on? Well, I'll just bend the legs up. Should be okay. All right. Back to diode. So out of circuit. That's the center. We got our 0.5 and oh, no, you're right. 0.5 on one and 0.5 on the other. Are they still shorted to each other? Yeah. Trash. Let's get our replacement installed. After we do some adjustments here, it should be good. Like I said before, you see how these are not sitting flat and I can wiggle them around? That's no good, so we'll take care of that. So we'll get this installed here. And well, it doesn't want to sit flat because you can see how there's a, maybe let's zoom in here. You can see how there's a, it's flared out. As this travels up, it gets to a certain point, then the sides flare out. So it won't let me sit it completely flat. So I'll have to get it as flat as I possibly can. The holes aren't big enough in the board for the flared out ends. Once you reach a certain point, it flares out, and the holes aren't big enough to sit flat. So I'll get it as flat as I can, which is right about there. It's as flat as I can make it, unfortunately. But it should be secure. You can look at it compared to the other two. So let's zoom back out. And we'll get this soldered in as flat as I can make it. We'll have to fix this. There we go. All right. Okay, now that we have our new one installed, we can test it. Not pretty, but this is just a big horror show like they always normally are. I'm not going to mess with the other ones because I want to see, they tested good, so I want to see if I have all my colors or not. And like I say, I'll come back and do this later after we test it. So let's do our meter here, and again, we should have 0.5 or 0.6. There we go, 0.6. Other leg should be open. Let's do it around this way. This was 0.6, and our other leg should be open. It is open. Are these two touching still? That's good. They are not shorted. Okay, well, we know our resistor is good and everything else checked okay, so let's put it on the tube, fire it up, see what we get. So we're all hooked up, count to 5, anode, neck, yoke, ground, video, and then if you want to count to 6, we got power. Test pattern generator, set to medium res, we'll go ahead and turn it on. Okay, I have not turned it on yet, so let's see what happens. Here we go. Oh, powered up. 2 for 2 on power up. Oh wow, we got an image. Flyback's too high. You can see the raster lines. Got full deflection, that's good. Let's turn our flyback down a bit until those raster lines go away. I don't know if you can see them. That's good. Really, the way you should do this is we'll turn brightness and contrast completely down, and then you can see we still have an image even with that all those turned down. Then we'll turn down our flyback until we lose our image completely, and then we turn it up till we just get it back. There you go. Then you can supplement with brightness and contrast. That's really how you should adjust these chassis. Oh, we've got something going on there. Contrast is, you can see this junk over here. When I adjust contrast down a bit, it goes away. Right there it's a bit overdriven. Right there is about where it's going to have to stay. And again, there's a sub-contrast adjustment down here. I don't know if you can see it. This pot here is sub-contrast, and it's exclusive to the 7500 if I'm not mistaken. So we might have to adjust that down a bit. Let's do that. Right about there. And it does the same thing when I turn the main back up. Well, we'll worry about that later. Let's scroll through, make sure we have all of our colors. It looks like we do based off our white balance here, but yeah, we got all our colors. Look at that. So there you have it. Working out of the box. Obviously we were missing. I don't know what color it was. I think it's, like I say, I think it was blue. It's red, green, blue from inboard to outboard on those transistors. I'm fairly certain we wouldn't have had blue, but we do now. We have some type of contrast issue, but I can almost guarantee it's because of the caps. The caps are all original, most of them. So I'm not going to worry about the contrast issue because the chassis is working and has a good clear image. As a matter of fact, let me see if I can get it even more clear because I haven't adjusted focus yet. Right there is pretty good. Yeah, you can see that. Look at that. Glorious. So, yeah, I guess number 2 is good. Nothing wrong with it except a bad blue color transistor. And here at the end here, I'm going to take all this back off and redo the neck board like I did on the first time. I'm not going to show it on camera for the sake of, how the video doesn't need to be another hour long. But I am going to go ahead and do it and then show you afterward how it turned out, and we'll test it one more time. So stay tuned here momentarily for that. But yeah, so far first 2 are successful. Just issues with neck board. And I always do burn tests on these. I'll let this run for a good 4 or 5 hours just to make sure nothing happens before I wrap them up, send them back to the owner. So just if you were wondering about that. So I'll get the neck board fixed up, and then I'll come back, we'll test it one more time, we'll call it good. So stand by one moment. Well, real quick here, I want to show an example of why you always want to do reflow and inspection. Because even though it was working, I found something interesting. I haven't messed with the neck board yet, that'll be later. I'm doing the reflow now. I didn't mention it before, but I always do reflows here before I mess with the neck board. But here's an example of why you always want to check. This is the power connector for your main input. And it's very, very, very common to see that. It is cracked. So you can see there's hardly any solder on it. These two have been, well, these are probably original, but this is cracked. So that's a really good example of why you want to do reflow on this and a good inspection for things like that. The power connector, your header pins for your video, the header pins for your neck board connector, header pins for your remote board connector, and sometimes your ICs here, you want to reflow your ICs, and especially your points here for your transformer, and anything else that looks suspicious, because sometimes people will change capacitors and lift pads, brake pads, all kinds of stuff. So it's always important to do a good inspection. So I'm going to do all that, get that reflowed, fix this, and then we'll get back to our neck board and I'll show all that off afterward, and then we'll get it tested one more time. So hang on. Well, all complete. As you can see, I got the resistors nice evenly spaced apart. We've got all of our heat sinks flat as they can be, and again, they're not as, this one's very strong, this one's very strong, this one is strong enough, but I can't get them any flatter because of the type and design of the transistor, which I already talked about. But they're all, somewhat equidistant. They're not bent over. They're as flat as I can get them. This is really how you kind of want to have these sit. You don't want to have them folded over or touching the heat sinks to the next one, because you're going to end up transferring heat, making them even hotter and burning out even more prematurely than they should be. But yep, and so here is the repair. And it's not a work of art, but it's a lot better than it was. I left the solder bridge ones that the previous person had done in place, but cleaned them up a bit, reflowed the transistors and some more parts and pieces. But you can see I just made replacement traces with component legs, just like before. And this one actually wasn't too bad, so I didn't have to do much with this one. These were actually somewhat okay. But yep, that's it. Cleaned it up as best as I could, and that's how it ended up. So it's not too bad. And let's zoom back out again. And one thing I forgot to do was wipe and clean these, wipe and clean these pots. And I always put them in the middle, because ideally you'd want to have them in the middle and then adjust from there. Alright, so I think we're ready to hook it back up, get everything going, and see how it turned out. Stand by. Well, once again, we're all hooked up, ready to go. TPG is turned on. Let's see what happens. Came to life, so that's good. And hey, that's actually much different, much better. I didn't adjust anything with this. And you can see how I left it versus how it is now here. We got our raster lines back again. So let's do some more. I'll turn contrast and brightness back down all the way again. And we'll turn our flyback back down till we lose our image, and then have it come slightly back. There we go. And turn our contrast and brightness back up. What is going on there? Oh, contrast is still too. It needs caps. Let me turn our sub-contrast back down. That's odd. There we go. Yeah, that as soon as you break contrast from right where it's at to there, that's too much. Yeah, I don't know if this neckboard has other issues. Without an actual game to run, it's hard to say. But the image is I got the brightness turned all the way up and it's still kind of dark. But it does have full deflection and full colors. So I wonder if I can turn this back up a bit. Fly back. There's good. Yeah, I mean, it's got a beautiful picture, nice, crisp, and sharp. You can see. I think we're actually good. There's our convergence page. Convergence is real nice, but that's the tube, not the chassis. Yeah, that's not bad. I'm going to call this thumbs up. I'd say give it some caps, and it's another working monitor. So yeah, it looks like the first two K7500s of this lot of 4 just turned out to be neckboard issues. So hopefully one of the last two will have some type of issue we can troubleshoot. So stay tuned for that, and we'll see if those give us any issues, and hopefully they do, so we can learn something. So stay tuned. Actually, you know what? I forgot to test the width operation. Width. We have width control. And again, that's all from this little transistor here. And I'm going to go ahead and disconnect it. And immediately, you can see the image shrunk on both sides. And I go back to my width and I adjust it, and nothing happens. So yep, little side note information on that resistor, or I'm sorry, on that transistor. So there you have it. Hope you learned something, and hopefully the next two give us an issue where we can try to learn something. So thanks a lot.